Hi, welcome to another webinar of the series of Analyze MyWorkpiece Toolpath. My name is Oliver. I'm the product manager for Analyze MyWorkpiece Toolpath, and this is now the fourth webinar of the series. And the fourth webinar will all be about analyzing time series data and understand the interaction with the point cloud. In the preceding webinars, you learned everything about importing data, so that's the first webinar. The second webinar was about using this menu to basically interact with the point cloud. And the third webinar, let's just load a file. The third webinar was about this menu and all the tabs from 4D to the measurements, T, selection, and so on. And now the fourth webinar will all be about analyzing time series data. So how do we do it in Toolpath? First of all, we need time series data. We don't have it there yet because we only have an MPF file imported, and an MPF file doesn't have a time domain because we haven't recorded any data yet. So first of all, let's load up time series data. For this, let me just close the file and let's look for a new one. And the one I'm looking for is this one here. So let's do the mapping. For time series data, you actually at least only need the position values, and that's all for now. You must make sure that your imported data contains time. And normally the operate trace files and also the files from Cinematic Edge, so from Analyze MyWorkpiece Capture and Capture for Analysis, they do contain time data. If you are importing a CSV file, a generic CSV file, then make sure that your data contains a time column, and you need to map this column here against the time, so to tell Toolpath which one is the time signal. And what is now very crucial here in this import window, and we never really talked about this checkbox so far, generate graph data, this should be checked. If it's not checked, then you cannot analyze time series data. By default it is checked, so let us check it here right now. And let's import it. We can see the spiral that we just have seen a couple of times now in the webinar. And there is a menu which is a little bit hidden in the current version of Analyze MyWorkpiece Toolpath. You see the small chevron here in the bottom, and if you hover over it, it says click to expand the signal graph viewer. So you can, let's just click on it, and now a completely new pane has been created. And this is the graph viewer. So first of all, before we can start analyzing stuff, we need to select a signal to be analyzed. And we have all the signals here also available, as we just have here on the 4D tab. So what always makes sense to have a look at is, as an example, the velocity. So if we select one signal, Toolpath now shows us the signal against the time, and that's why the time signal needs to be imported. Otherwise Toolpath does not know how to map these points. You can now start your analysis, or you can even select another signal if you say, okay, I do not only want to have the velocity, I want to have the acceleration. You can import multiple graphs if you want to have the jerk. Also possible. It's totally up to you. And now you see, this becomes now a little bit difficult to read. It's very small. So either you expand it like that. For sure it's a compromise because now the point cloud becomes quite small. Another alternative, which I personally do not like that much, is you can tile it vertically. And if you click this button again, you can, tile it in a matrix kind of style. But as I said, I prefer tile horizontally. Okay, and if you think that 3 graphs is too much and you don't want to look at them anymore, you can select them again and uncheck them. So for now, let's have a look at the velocity signal only. And now we see that the point cloud contains here this line and then the spiral. And here we have the map signal against it. So what can we do? We can actually do a lot, and let's go through it step by step. First of all, we can make sub-selections here inside the time domain. This you can do by clicking and holding the left mouse button. If I now move my mouse, I can select the area of time which I want to analyze further. So let's just say since this is velocity, we see several parts. One is with 3000 millimeter per minute. So this was here on the left. Let's restore it. This is the 3000. I don't want to see that. I only want to see this area here where we have the feed rate of 1000, or probably, let's hover with the mouse over here. Yeah, we see with the balloon tip what are the values here. The first value is the X value, so that's 47 seconds, 47.93 seconds, and the second value is then referring to the velocity, which is like 999, so nearly 1000. So let's select this. And what you should have now recognized is that this strip disappeared, this line. And that's due to the fact that zooming into a time domain also leads to changing the visible points. So it's a little bit similar to this eye symbol. When you select points, which you have learned in the second webinar. And if I zoom now even closer, let's say, okay, what is going on here? We now see, all right, okay, this is only here the top of the spiral. And if we want to go back, we have two possibilities. We make a right click into the graph and say either undo, so we go one step back. Yeah. Or if we click restore original view, well, then we have all the data again, and also in the graph we see all the points. Yeah, there is also a zoom in, zoom out button, but then Toolpath guesses where you want to zoom, so I suggest always to use this feature. You can, if you want to, also change a little bit the appearance, like you can change the series color or the threshold color. What the threshold is, you will learn in a second. Yeah, let's change the theme, but personally I always go with the... Ooh, this is like very bright. It's just blue icy. Yeah, I go with the black default theme. So what else can I do? Let's start with this button here. The second on the right, saying show point selection on graph. If I click it, and then I do a selection in the point cloud and not on the graph. I do this by holding the left shift key on the keyboard, clicking and holding the left mouse button, and then I can draw this rectangle. And if I release it, then Toolpath selects all the points that are referring to the selected points here in the graph. So let's undo this. I can either use the deselect points, or I use the north pole, so the N button on my keyboard. So the selection is undone, and now I zoom in and I say, okay, I'm interested in what is going on here. And now Toolpath selects these areas. So the points don't have to be adjacent to each other. It can be a multi-selection, and still Toolpath shows the respective points. And it also works in the other direction. So if I click this, select points shown in graph, Toolpath now selects every point here in my scene. And why is this the case? Because currently I see the whole time series signal. So if I zoom in, let's say, yeah, again, I want to see what's going on here because the velocity seems to drop here quite dramatically. Toolpath now selects these points and keeps the rest of the scene visible. So sometimes you don't want to hide parts of the scene, but you want to select the points. You should keep in mind that this I button here on the right, which you have learned what it does in the second webinar, it does not work as long as you have the graph viewer active here. For sure, you can still activate this point, this button also, then the points get selected, but that would always lead you to a red curve because you would always see the selection. So it doesn't really make sense. Okay, let's unselect the points now and restore the original view. What else can we do? So there is this button here saying Synchronize graphs on zoom. So currently we only have one graph, so that would make a difference. Just let's get the curvature here, and or let's go back for a second and let's take the acceleration. And yeah, assuming we want to zoom in into this area, what happened now is that the velocity graph, it got zoomed into, but not the acceleration graph yet here on the bottom. So in order to do so, let's restore the original view first. Let's click this button. Now the two graphs are synchronized. So let's say if I want to zoom in here, now I see the velocity here on top, the acceleration on the bottom, both synchronized, and yeah, if desired, the point cloud selected. If we click this, then we see it with a selection. So this is done with the synchronized graphs on zoom. And this is very handy if you, let's say have multi-dimensional data and you want to have a closer look what is going on with your machine tool as an example. Let's just restore this and let us now start to work with the thresholds. So first of all, if you want to work with thresholds, so far this can only be done when visualizing one graph. So let's get rid of the acceleration for now. With Toolpath, you can visualize multiple threshold types. One is a single threshold type. So you now see a new line, a horizontal line, and this line can be adjusted. And let's say we put a threshold on 950. So that means 950 millimeter per minute for the velocity. And the question that I would like to answer in my workpiece is, where in my workpiece do I have speed drops? So I say, okay, first start with 950, or let's say 999, and then invert areas. And that now means that Toolpath is now, oops, that was a glitch. Toolpath is now inverting the threshold and showing to me the areas in my workpiece. Okay, I think 999 was a little bit too big. Let's go with 990. And Toolpath now shows me all the areas in the workpiece where the threshold was lower than 990 millimeter per minute. And this is very interactive, so if I move it back, I can see more of the workpiece again. It also works with double threshold, so if you want to look at a specific, very close area, like show me everything that is outside between those two values, I can invert it. So now we see the areas where the tool is either very slow or very fast. That's why we see this line here again. Or you can, again, make it like that. Then you see everything that is in between. So the thresholds are also very important to find areas where there are certain boundary conditions set or met. This you can switch off. We're using no thresholds, and then you are on the original view again. There is no, there are two more buttons you can see here: G-code, series, and tool change. So when you have a recording coming from Analyze MyWorkpiece Capture or Capture for Analysis with Cinematic Edge, you get additional context information. So first of all, let's import data, file coming from Analyze MyWorkpiece Capture. And let's do the mapping here. We do a basic XYZ mapping, and what we additionally also now map, just that you have seen it once. Let's take the spindle torque again and import it as a custom signal. So I click here and I type in a new name, spindle torque. And I make sure that the generate graph data button is clicked. So Toolpath is importing the data, building the new scene. Let's expand it. And this is our workpiece. Let's get the graph viewer out and let's say, okay, we want to visualize the spindle torque. And yeah, this can be seen now here. And what we now also see is that here are red and gray areas. And if we uncheck this box here, then they disappear. So what do they mean? They actually show you where are areas where you have a G1 movement and where you have a G0 movement. Or let's say red means non-G0 and gray means G0. And this tells you, it shows you where the machining actually begins, like the machining on the workpiece. So if you want to analyze something very closely and you want to understand where in the workpiece the tool really entered the workpiece, like the material, then you want to look for the areas where you only have a non-G0 section. So this would be now here, and now we see, okay, that the spindle torque goes from 0 to roughly 1.7. So we now also could use a color coding and say, okay, limit it to 0 and 1.8, or let's say 1.7. And let's make it a little bit more narrow, and then we can see, okay, where has the spindle torque been a little bit higher compared to the rest of my toolpath. So assuming you want to understand whether there are outliers, if you want to do an outlier detection based on the spindle torque, you can use here those red and gray areas. And if you want to be a little bit more precise, you can also visualize the tool change instance shown here with this green line, yellow line, I'm sorry. So let's zoom in here, and now we see here this dashed line, and it says active tool change to 287. So that's an internal identification representation of the tool management. And this is now a new tool becoming active. And again, here in the red areas, we see that there is a non-G0 section. In this case, it's a G331. So we would zoom in here again and now see where the spindle really had to do some tasks. So, and by using this, you can understand also what is really happening here on my toolpath. Is there anything unusual? So let's just set the thresholds as we see them, and we now can see in the workpiece what happened there. So let's restore the original view. And yeah, this is basically the graph viewer. You have to basically understand what's the question that you would like to answer, and with the graph viewer you get a powerful tool at hand to really find this out. So finally, to end this webinar, I would like to show you what you need to consider when you are working with a CSV file. So with the CSV file, as I said, make sure that there is a time column. I created an arbitrary CSV file here, which you probably know from the first webinar. And this time column, well, it should contain double values and with a representation of seconds. And if we now import this one here, so let's just drag and drop it into Toolpath. We must execute a mapping. Since I already did it once, Toolpath recognizes this, but if it, if Toolpath has never seen the CSV file before, it would look something like that. And you would first start mapping the position like XYZ. And then what is really critical, you need to tell Toolpath which column is the time column if you want to visualize graph data. So therefore, select the signal, which is the time, and take the symbol name time, and then as a mapped signal you have to select scalar. And now you can import the data, and besides having this quite small point cloud here, you can also, as an example, visualize the position or velocity, which doesn't really make sense in that case since it's just some test data to fool around, but I think you get the basic idea. Okay, that's everything you need to know about the graph viewer, a very powerful tool. I hope you enjoyed this webinar. So thanks again for listening, and see you next time.